We've got new sunspots. We've got coronal mass ejections propagating as we make the video. We'll talk about solar layers and lots more. And welcome to the Daily Space Weather. The main feature here at the Smash News Network, least busted name in news. Make sure you check our playlists for all kinds of other content besides the Daily Space Weather. A little bit about the origin of the videos. We noticed that there was nobody covering Daily Space Weather, at least not in a coherent fashion. And there were certain variables that we wanted to look at to tie them together with reality, aka observations, hence these videos. Congratulations on realizing that they exist. This is SDO 171 angstroms, that's ionized iron on the closest star for the past 24 hours. Again, we do have some new sunspots, so let's add 131 angstroms to this fantastic SDO imagery, the Solar Dynamics Observatory. That'll help to highlight the active regions. Likelihood of large solar flares remains very high, as we've got a very magnetically complex sunspot group. In your screen lower left, that's the southeastern limb. Also, a new sunspot just rose in the northeast, and two new sunspots formed also in the eastern limb. So that's where the action is at the moment, in the eastern limb, although the CME came out of the northwest. Again, we'll get to that. Here we've switched things up. This is 304 plus 193 angstroms. The likelihood of major coronal mass ejections remains very high, as we've got a massive number of filaments. You can see all these absorption features up here, all these dark features, as well as prominences all around the limb. Expect coronal mass ejections, and we'll show you some a little bit later in the video. First, yesterday plus today in SDO continuum. Again, you'll see a new sunspot forming right here, and another one up here. Just in the past few hours, also another sunspot just rose up here. So we're likely to get 3 new named sunspot groups today. Here is the SDO colorized magnetogram, which, by the way, is showing you the photosphere. The photosphere, and we will talk about the outer layers of the sun. In the meantime, please take a moment to press like, subscribe, share, etc. Thanks for leaving a comment, TinMan1057. And in the video's description, you may find links to the Redbubble shop. Today's featured product is Do Not Pole Vault the Caldera. The colorful design is a public service message brought to you at massive personal risk and expense by Smash staff and I. No matter how bad things look, don't worry, folks. They can get worse, a lot worse, but our finest days lie ahead. So don't pole vault the caldera. If you're going through hell, keep going. That's a quote from Winston Churchill for you. Hopefully that's motivational. And by the way, if you want to see content about things like lifestyle, fitness, and diet, hit us up on Instagram. Links below the video, as well as on the homepage at smashomash.com. Let's briefly talk about volcanoes. And there was something a little bit horrifying happening yesterday. That is a pyroclastic flow coming from Semeru. Yes, Semeru. So not sure if it did any damage. That village looks a little bit uncomfortably close to the pyroclastic flow there, which is hot gas, ash, and dust and rocks of all sizes flying down the volcanic slopes, often at very high speeds, and they even accelerate when they go across water, by the way, which is pretty creepy. Anyway, that's the current situation at Semeru. Well, it happened yesterday. Let's check the rest of the list here. Subanose-jima is also indeed erupting and producing a 6,000-foot plume of volcanic ash. Semeru's eruption produced a 14,000-foot volcanic ash plume yesterday. That's a flight level 140 over the East Javan volcano. Stay 5 kilometers away from the summit, says the Volcano Observatory. Dacono also exploding, flight level 070. That's a 7,000-foot ash plume. 20,000-foot ash plume over Popocatépetl in central Mexico. That's a flight level 200. Fuego exploding in Guatemala, flight level 150. Nevado del Ruiz exploding in Colombia, flight level 210, and Sabancaya exploding in Peru, flight level 250. That's a 25,000-foot ash plume. And a quick reminder, don't pole vault the caldera. If you're going on a volcanic vacation, leave your vault pole at home. So here are the past 90 days of global seismicity. We'll briefly cover earthquakes here, as there's been a little bit of an uptick since yesterday. Several 5-magnitude quakes have happened, as well as quite a few on the west coast of the U.S. So, of course, mainly around the Pacific Rim, some also around the Indian Ocean. So let's check out what's going on. First of all, there was a 5.2 yesterday at around 14:11 Universal Time. That was near Papua New Guinea, just north of Australia. Quick reminder, any earthquake can be a foreshock. So realize this if you are around a quake like this one, this 5.3 near Fiji. That could be a foreshock portending a larger quake coming in the future. Who knows? Also, there's a 5.1 at Alaska, out in the Aleutians there, near the Alaskan Peninsula. That was at 20:25 yesterday evening. And if we miss anything, just let us know in the comments what we missed. 5.1 at the Mid-Atlantic Ridge also occurred at 1:21 this morning. And there's one of those Indian quakes near the Nicobar Islands, around the east coast of the Indian Ocean there. That 5.4 happening at 7:46 this morning, and then less than 2 hours later, a 4.6 there in the same region. Perhaps that is calming down, although then we see a 5.5 having happened more recently at 10:31. So again, could be a foreshock to a larger event. Please be aware of this. And let's get back to space. One of the classic wavelengths to view here is ionized helium. So the SDO 304 angstroms wavelength, always a classic. You can see those new sunspots forming. It's also great at showing filaments and prominences. It's also good at showing flares. Lots of helium around those active regions, especially in the southern hemisphere. The 10.7 centimeter radio flux is still at 136 solar flux units, and we can expect to see this increase in the coming days, not only with new sunspots, but with a very magnetically complex sunspot moving into the Earth-facing zone. There's your one-year graph of your 10.7 centimeter radio flux, which, by the way, emanates from the upper chromosphere and lower corona, which is right about there. Right about there. And again, we'll talk about layers of the sun here in a minute. The red line is the sunspot number, the black line is the radio flux, the pink line is the smoothed sunspot number, and the blue line is the AP. That's the Potsdam AP index, a measurement of global geomagnetism. It's basically the KP index over an average. Now, we are expecting a coronal hole high-speed stream here to show up late in the day, somewhere mid to late day on the 11th. So we are expecting a little uptick, and it looks like NOAA might be on the same page with us here, as NOAA is forecasting a little uptick in the KP index. Again, there are coronal holes. We can expect a density increase showing up around mid to late day on the 11th. Besides that, no significant space weather is in the forecast. Let's take a look at Earth's magnetic moment from space for the past 4 hours. Keep in mind this data is derived from This model is derived from various different data points. If you want to read about the space weather modeling framework, just click this Details tab right down here. That will direct you to a link for the space weather modeling framework. You can download and analyze the software yourself. It's from magnetometers in space and on the ground, and at Lagrange point 1, measuring the solar wind and the magnetic fields and so on. It's quite a complex model. However, if the data is showing errors, you'll see errors in the model. So just so you are aware of that, that's the last 4 hours of Earth's magnetic moment from space. Here's Earth's magnetic moment from the ground. This is based on the same space weather modeling framework. Again, just click the Details tab on the Geospace Magnetosphere Movies or Ground Magnetic Perturbations page to be directed to the space weather modeling framework link. Things like the electron flux also figure into this. Next, the planetary K-index is at 1.33. It's geomagnetically calm conditions indeed. KP is 1.33. And let's go to the real-time solar wind. Again, that's measured at Lagrangian point 1, about 1 million miles away from the Earth, and about 92 million miles away from the Sun. So here's the data from Discovery. And you may discover that you don't like the data from Discover. So you want to look at the data from ACE also. Well, there's the data from ACE. So ACE is showing a signal here around 330 kilometers per second for the solar wind speed. Solar wind density here below 1. So quite low there for the solar wind density. And very diffuse solar wind here showing up on the Discover's data as well. So a sputtering, very diffuse solar wind there. Solar wind speed here, 334 kilometers per second. Solar wind density only 1.2 protons, 1.25 protons per cubic centimeter. 1.25 protons per cubic centimeter is a very diffuse solar wind. So if you want to look at the ACE as well as the Discover, it'll tell you up here which spacecraft is being used right there. You can see it says active is the Discover. If you scroll down to the bottom of the page on the Space Weather Modeling Framework, you'll find this ACE real-time solar wind. If you click that, that will show you what's going on with the ACE. So anyway, diffuse and slow solar wind, we can expect a significant signal in about 2 days. Next are magnetic data. There are your GOES magnetometers. They measure the Earth's magnetic field from their geosynchronous near equatorial orbits. Fairly smooth here for the past few days. And next, the heliospheric current sheet. So this top view ecliptic plane field plot is super important as it shows us crucial features to the solar sunspot cycles, like this one. This coronal hole hanging out at the north heliographic polar region. That needs to leave before solar max is achieved. So anyway, that's what's going on. Earth is right in the middle of a North Pole-oriented current sheet depicted here in green. South Pole current sheet on the opposite side of the sun at the moment. We may see some weak magnetometer readings on planet Earth based on what I see there. Let's take a look at our line of sight field plot. So there is our line of sight field plot. And again, Earth is sort of right in the middle of a North Pole-oriented current sheet, as you can see here. And let's move to coronal holes. So coronal holes are a super important portion of the solar cycle process. The coronal holes show us the solar polar magnetic field process and its reversals. So of course, as the solar cycle progresses, the green, which is the north coronal holes, those will be headed down to the south, and the red, which is the south coronal holes, they'll be headed up to the north, and they'll become fixated there as we approach the next solar minimum, expected around 2030, by the way. So that's what's going on with coronal holes, and let's bring up some SDO. Let's bring up some SDO imagery also. First, we'll bring up the latest image here. So we do see some South Pole coronal holes here showing up, recently opening up there in the northwest. Besides that, they're all North Pole. So this is yesterday plus today from the SDO 211 angstroms wavelength. These coronal holes up here, the South Pole ones, aren't too visible. It looks like they've just opened up, actually. Yeah, so that's pretty awesome right there. You can actually see a coronal hole opening right there. Some significant plasma reorientation happening there. And yeah, the rest of those, these are all North Pole. And these couple little ones up here are south. And that is a terrible looking S. All right, so let's talk about solar layers. And we're not going to go to the layers below the photosphere. So we're only going to talk about the top 3 layers. These are the layers that we cover on the videos. So first of all, you've got the corona. That's the sun's atmosphere. As you can see here, all of this ethereal looking material out here, that is the solar corona, the sun's atmosphere. It's the hottest part. And then below that, you've got the chromosphere. Now, it's just pointing to this. I'm going to show you the chromosphere in a much better capacity than this. This is actually from NASA. So this is just NASA's diagram of solar layers. And again, we're not going to go below the photosphere here because, well, it might not be science, but we can see the photosphere. So, you know, the corona, chromosphere, and photosphere are certainly science. Sunspots and the magnetic fields imagery that we show, those are the photosphere. So when we show the SDO HMI imagery that shows sunspots and magnetic fields. That is the photosphere. Just above that is a thin layer called the chromosphere, where there's a huge temperature variation between the photosphere and the chromosphere, and then last but not least, another huge temperature variation between the chromosphere and the corona. So here's some great imagery. Sunspot 3272 here, and this is a perfect breakdown of those three outer layers. So let's zoom in a little bit closer here. So this thin black region you see right there, that is the chromosphere. There is a lot of stuff going on there, as there is material. Well, there's material going in both directions, frankly. But the chromosphere is the layer in between the corona and the photosphere. You've got to look at certain spectra there because the temperatures are so vastly different. So when we look at the corona, we're looking at the ultraviolet emissions primarily from the material in the corona. The chromosphere lines are completely different, and that is something that we'll actually cover on the channel at a later point. It's not really that much of an issue as far as space weather, but as far as heliophysics, it's super important because there's a lot of stuff going on in the chromosphere layer. So anyway, what this is showing you is sunspots, which are at the photosphere layer. And you can see right there where you see it get like solid looking. And then that little thin black layer, that's the chromosphere. And then last but not least is the corona, the outer portion there, the sun's atmosphere. So let's move to sunspots next. We'll have likely 3 new named sunspot groups today, and the likelihood of major solar flares remains very, very high. Probably like an 80% chance of M-class flares, and maybe like a 40% chance of X-class flares from 3272 especially. Again, there's a new sunspot right up here, and another one up here, and another one just rose up here in the northeast. So here is a view of the photosphere. That's the past 24 hours. Here we've added 171 angstroms to help highlight the active regions. You can see all of that ionized iron in 171 angstroms aligning to the magnetic fields associated with that active region, especially down there in the southeast. A perfect example of that. Let's zoom in a little bit closer here. Again, you'll see 2 new sunspots form. One right there, and then one up here, which looks like it's pretty active already. So a perfect example there of how the magnetic environment can suddenly change. The sun is not shutting down, period. So no matter how much fear-mongering and nonsense is on the internet about the sun shutting down, no. And by the way, just a quick fun fact. If your model relies on certain things to occur and none of those things occur, your model is probably incorrect. Therefore, if your model for Armageddon requires a grand solar minimum, you should abandon your model for the apocalypse. Because if a grand solar minimum is required for your model is not reflecting reality. Anyway, let's move on to energetic particles next. The proton flux shows no spikes. Flaring has been minimal. And there is your X-ray flux. And another quick note, don't get solar flares and coronal mass ejections confused. Solar flares are X-rays, which are light, aka photons. Photons, light. Coronal mass ejections are gas, mainly highly charged particles known as hydrogen nuclei. It's hydrogen nuclei that lack an electron, also helium, and electrons, and also some other heavier elements make up the solar wind. That's a coronal mass ejection. Protons. Solar flares are photons. Largest flare of the past 24 was this nearly M-class flare. It was just before 6 o'clock this morning. Peak flux was about 9, about a C9, so almost an M-class flare, and it came from this active region. No surprise there. Sunspot 3272 is certainly the most likely place to see additional large solar flaring activity. So this is another 24-hour video here for you. And the reason we show 94 and 131 angstroms is because those wavelengths take 10 images per minute instead of only 2. So when we see large flares and so on, Those are great wavelengths to slow things down and get a little better understanding of what's going on. That might not be evident at 30 frames per second, which is what we're showing here. Next, a brief look at what's going on overhead. So this is a star chart for Lehigh Valley. You can see Jupiter and the Sun very close together there near the ecliptic, and also Mercury trailing. So if you're looking at the sunset, give it a little time, you might be able to see Mercury there trailing the Sun. And also the Moon is in the process of setting here in Lehigh Valley. If you want to make your own star chart, head to skyandtelescope.org. Just put in your zip code or whatever, your city, zip code, location, yada, yada, yada. And here's your solar system forecast. Now, of course, there's lots of doomsaying about Jupiter, and the alignment between Jupiter, Earth, and the Sun is very scary and spooky, and Jupiter controls solar activity and so on. There's going to be a huge disaster. I mean, every time there's any kind of a planetary alignment, there's just an endless supply of nonsense on the internet about it. And, you know, every time nothing happens, nobody says anything. And anytime there's a correlation, everybody says, you see, the planets control the Sun. And it's just ridiculous and pathetic. A failure of the education system and people's ability to understand basic physics, or certainly astrophysics. Anyway, here's your solar system forecast. That's where things will be on April 16th. We will have a crescent waning moon on the 16th of April. So we did have some coronal mass ejections, and expect lots more. You might be wondering if those are earthly directed, if you should get in your bunker, etc. And the answer is, well, we don't think so. So those are yesterday's images from George Mason University. Only 54 frames for whatever reason. Here are another 17 frames from today, and you can expect coronal mass ejections to continue. Let's take a look at some more data here from Stereo A and the Soho-Lasco C3. So here's Stereo A on the left, Soho-Lasco C3 on the right. Again, a quick reminder here, Stereo A is only a few degrees behind the Earth at the moment, so it's not giving us great ability to calculate the trajectory of coronal mass ejections. But we're not really seeing any indication that we have any Earth-directed ones. So there's one coming out of the west, there's one coming out of the east, and there's one happening right now coming out of the northwest. We'll let those play through, then we'll show you some 24-hour videos. As we like to be complete with our coverage of space weather. Basically, folks, you've got to look at the same data every day. Otherwise, you're not going to understand how the data correlates. Anyway, that's what's going on. Here's the past 24 hours. We've got SDO 193 angstroms. We've got Jupiter in the lower left. Soho-Lasco C2 in red, Soho-Lasco C3 in blue. Let's get a little closer here. We may have to make another video about the currently occurring coronal mass ejections. Here's an even closer view. There could be Earth-directed components there, as we do see some limb darkening and some other features that we do see when we have an Earth-directed CME, although I would suspect that it is not earthly directed. Here's the past 24 hours in just the SDO 193 angstroms wavelength. Pretty good view of that coronal hole there. You can definitely see some material up here on its way out. We'll let it play through one more time. Also, you can see that coronal hole in the northwest forming there of South Pole orientation. And let's move on to filaments. So we've got massive filaments on the Earth-facing portion of the solar disk. Again, that's why I say consider the likelihood of coronal mass ejections to be nearly 100%. We've got prominences all around the disk. There's a huge filament up here at the crown. See that crown filament up there? Not showing up as a prominence. It's pretty tight, close to the chromosphere there. But you can see an absorption feature there. That's an indication that there is a huge filament up there at the North Pole. So huge filaments, 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 and more filaments If you want to name filaments after living humans, join us on Twitter. Follow the hashtag #NameThatFilament. And follow us on Twitter for all kinds of other reasons as well, things that have nothing to do with space weather. As we barely use Facebook. Yeah, Facebook, some of the most pathetic software ever written on the internet. It's even more pathetic than Google's junkware. And, you know, Twitter is also pathetic and full of shadow bans and just utter nonsense and the promotion of fraud and propaganda. However, it's a little bit more elegant than the Google and Facebook junkware. Twitter, join us over there. It still barely functions, but social media, I mean, we need to use it for business purposes. So anyway, join us over there. Again, all kinds of information that you won't see anyplace else, just like on the Smash Team site, by the way. So there's the past 24 hours and 304 plus 171 angstroms. And here's the past about 2.5 hours. And you can see at least the tail end of this CME, the one from the northeast, right up here. I would say if either of those CMEs are earthly directed, this one from over here is the more likely one to be earthly directed. I'll have to wait a few hours to get any more information on that to make any sort of valid predictions. Anyway, let's move to our bonus features segment and blast through those. We don't want your video to be too lengthy. First, the satellite's community dashboard showing no charging hazards, so you can expect smooth sailing for your satellites, at least at the moment. The electron flux here just in a moderate range. Nothing to write home about there. Those are measured by the GOES 16 and GOES 18's radiographic measurements. There is the relativistic electron forecast model. And I would definitely agree with this one. Looks legit to me. That's the arrival of a coronal hole density wave. There's the one-year chart to put the relativistic electrons into context. Again, we're just in sort of an operating range here, near the moderate to high portion. And let's take a look at the ionosphere and the vibrational frequency therein. The F layer, it's at about 300 kilometers of altitude. Feel free to pause the video on this frame if you're not familiar with the penetration of electromagnetic radiation into Earth's atmospheric layers. For example, the reason that we don't measure X-rays from the surface is because we can't. They're filtered out by the time they reach a stratosphere in the mesosphere layer. So here's the vibrational frequency of the F layer of the ionosphere, the bridge between Earth and space. This is the point where space weather becomes Earth weather. If you're not familiar with that, don't worry, we'll show you the anomalygram. This is the anomaly in megahertz from a 30-day median. Quite a few low-frequency anomalies happening here. So we see some significant low-frequency anomalies happening around the northwestern U.S., for example. Also central Canada. Now, of course, most of the anomalies are always going to be focused around the South Atlantic anomaly. That's the weakest point in Earth's magnetosphere, right where my pointer is. You'll also see lots of anomalies around the equatorial African coast, the west coast, that is, as the South African anomaly is somewhere around that area. Anyway, we show the data daily on the channel. It's one of the many examples of immersion in the actual data may provide you with results that you weren't looking for. So when you immerse yourself in the data, folks, sometimes you end up with answers to questions not asked. Anyway, there's the latest image. That's 11:45 universal time ionogram and 11:45 universal time anomalygram. The total electron content shows the free electrons between your GPS satellite and your handset, and free electrons in the way of your GPS satellite between your GPS satellite and your handset can cause signal refraction, which is what is causing GPS errors. So this will show you the most likely spots for those GPS errors. It's our total electron content forecast. We'll also show just the North American anomaly And here's North America. That's anomaly from the 10-day average, and actually some very low electron contents there over portions of the U.S. So anomalously low electron contents, at least based on the 10-day average. And let's close out the space weather section of the video with the latest solar intensity gram and latest magnetogram. So first of all, we've got this new sunspot that just rose right here. So far, it's only alpha class. I only see one umbra. This new one down here is quite promising. It's... What's up with that? It's beta gamma class. It looks like it's moving to beta gamma delta class. So the likelihood of a large flare coming from this new sunspot is getting a lot higher. So just in the past few hours, it has grown significantly. Here's 3272. Dag, that thing is spectacular. That is a complex sunspot indeed. So that remains beta gamma delta class, and by far the most likely spot to see an X flare. And don't forget about this new group right here also. That looks like it's already beta gamma class. I see two umbrae. I suspect they are of opposite polarity. So there you got a prime example there. Beta gamma delta class sunspot. You've got the leading South Pole umbra and the trailing North Pole umbra. Here's your full disk rock back. And let's move to Earth weather. Check it out. We're looking at the hottest place in the world. I think it's the hottest place in the world. It's about 110 degrees in Central Africa there. 109.4. I believe that is the hottest portion of the planet. Looks a little bit hotter than India, which is also on the hot side. Coldest part of the planet, maybe not surprisingly, Antarctica there, as it's now autumn in Antarctica. There's some very cold areas there. 71 degrees below zero there, Fahrenheit. That's on the chilly side. And it's spring in the northern hemisphere, so things are warming up there. And we'll take it. All right, so let's do our normally scheduled meteorology segment here and blast through. These are the surface winds of this side of the planet. These are the jet streams of this side of the planet. Some backward jet stream there over the western Pacific. Here are the jet streams of the western world, the Americas. Surface winds shown here. Surface winds of the central world. And the jet streams for Europe, Africa, and the Middle East. What about clouds and fog over the Americas? We've got it covered. That is the NASA GOES interactive weather satellite, which depicts the croissant-shaped planet on a fake Adobe Photoshop spherical template to trick you into thinking that Earth is shaped like a sphere, where our regular viewers are well aware that Earth is shaped like the French breakfast pastry known as a croissant. Next, our weather.gov map, and look at the flooding potential in the northern U.S. We called it. Look at our thumbnails. Since they contain more information than entire channels worth of content. YouTube.com/smashomash/videos. If you look back a few days ago, it says expect flooding. And there you have it. It's caused by temperature increases and record snowpack for the northern hemisphere for a 7th consecutive winter. So that's what's going on. There's your weather alerts from weather.gov. If your location's lit up, click your county at weather.gov, the National Weather Service website. Let's take a look at some forecasts. So since temperature is a thing that you're probably a slave to. Yeah, it's too cold now. It's too hot, too cold, too hot, constantly. Well, it's getting too hot for snow to remain crystallized. So that's your 72-hour GFS temperature forecast in degrees Fahrenheit. Please heed those flooding warnings. If you are downstream from massive amounts of snowpack, be aware of all of that mass. We'll also show the temperature anomaly forecast. This is degrees Celsius this time, and it is also the 72-hour GFS forecast. So anomalously warm temperatures here come into large portions of the north and western U.S., even coming here to Pennsylvania. We'll take it. And we'll also show pressure and precipitation. So here's the same model. Once again, the GFS 72-hour model, pressure and precipitation. And we're expecting some extreme weather here to strike Louisiana. It even looks like it's going to stagnate there. New Orleans, be ready for that. That looks like it could be additional tornadic activity. So I don't see huge pressure gradients forming there. Well, now they get pretty big. Oh, those are huge pressure gradients. Right there. You see all those lines coming together? Those are isobars that are connecting the like pressures. And when you see a lot of lines coming together at the same place, that means a massive pressure gradient right there. So be prepared for that. Damaging wind, hail, and possible tornadoes coming to Louisiana. Next, let's look at our soil moisture anomaly. So this is one of the great features of windy.com, moisture anomaly. So you can also look at just the raw soil moisture. You can see the central part of the U.S. is kind of dry. However, parts of it are becoming anomalously moist. And let us know in the comments if you're anomalously moist. All right, so here's our NASA GOES lightning mapper. We do see some artifacts showing up here. Check it out. You see an artifact right there. Where is it? Where is the artifact? Okay. I'm going to press refresh because there was clearly an artifact, and now it's clearly not there. There you go. Check it out. That's probably caused by charging hazards on the satellite, as it doesn't look anything like lightning. Right there, off the coast of Newfoundland. Anyway, let's check a real-time lightning map here to see if we have any current terrestrial strikes in the U.S. Some off the coast of Florida there. There may be some here in Texas. Minor thunder shower there. Also in, looks like the Oklahoma Panhandle there. That's a real-time lightning map from lightningmaps.org. And let's close this thing out with U.S. Doppler. Let's close this thing out with an ad. Yeah, an ad. This video was brought to you in part by our latest affiliate/sponsor, Hemp Lucid. If you want to support the channel and perhaps your own health, pick up some products from Hemp Lucid. Shop by solution. Check out the gummies. Or perhaps the CBD tinctures. Don't forget to enter the promo code SMASHOMASH to save some dough on checkout. Just click our link at the bottom of the video or on the homepage at smashomash.com. Thanks to Hemp Lucid and everybody who's picked up products. And thanks to everybody who's left commentary about how good the products are. Again, you can find all that info on the homepage at smashomash.com, the official homepage of the Smash News Network least busted name in news. And welcome to the Neo-Renaissance. Turns out we're not the only people saying that there's a Neo-Renaissance happening, as there is an awakening. And an awakening of the fundamentals of science. There are about to be some major advances, not only in human technology, but in things like cosmology. We're pushing that forward. It's part of the reason why we cover heliophysics. And these videos, by the way, were brought to you in part by the Smash team. So thanks especially to the Gold and Silver Smash team members. They are keeping this channel afloat somewhat. It's sinking. So consider joining at the Gold or Silver Smash team level. The best value is the Gold annual paid-up subscription. Smashomash.com/Smash team. Our official subscription services site launched back in October of 2021. Get additional content by becoming a Gold or Silver member, especially get email alerts, even at the Bronze level. And if you'd like a custom @smashomash.com email address, maybe join us over there. Join at the Gold level. If your name is Steve and you'd like steve@smashomash.com, that, I believe, is still available. It only requires 1 month of a Gold membership, and you'll have an @smashomash.com email address. Anyway, here is the U.S. Doppler radar map to close this mother out. We're focusing on the lower 48. There is the clouds and fog scenario. And there is the water vapor map. Mostly dry air here east of the Mississippi. Here's your recap. And happy Easter, by the way. U.S. Doppler radar. Clouds and fog. That's the 3.9 nanometer infrared radiation emissions of the clouds and fog, part of the NASA GOES Interactive Weather Satellite Suite. And there's the 6.19 nanometer radiation, otherwise known as water vapor. It shows all the water vapor. And so you should be able to see some distinctions between dry and moist air. Anyway, it's time to close this thing out. And thanks for tuning into the Smash News Network, least busted name in news. Don't forget to press like, subscribe, etc. We'll see you soon with some more content. In the meantime, I'll have been your host, Dan, a.k.a. Smashomash, signing off, and may that solar wind be at your back.